Good morning to all. I am Dr.Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kerpuram, Bangalore. Today I am going to discuss about fifth session of chemistry and which is first session of gaseous state, which belongs to first semester BSc affiliated to Bangalore North University. In this session, I have to discuss about Maxwell-Boltzmann molecular velocity distribution law. Now, main objectives of these sessions are need for Maxwell-Boltzmann distribution law. Second one is expression of Maxwell-Boltzmann distribution law. Third one is silent features of Maxwell-Boltzmann velocity distribution curve. And fourth one is nature of Maxwell-Boltzmann velocity distribution curve. These we have to discuss one by one in this session. Then after completion of this session, what you have to know about, you will gain there is a knowledge about what is the need of Maxwell-Boltzmann distribution law, then expression of Maxwell-Boltzmann equation, then what are the silent features of Maxwell-Boltzmann velocity distribution curve, and what is the nature of Maxwell-Boltzmann velocity distribution curve, you come to know after this session. Then before start this session, you have already known about gaseous state of matter. Now here usually matters are exist in 5 states. First one is solid state, second one is liquid state, third one is gaseous state, fourth one is plasma state, and fifth one is Bose-Einstein condensed state. These are the 5 states of matters are there. But in chemistry we will study only 3 states. One is solid state, second one is liquid state, and third one is gaseous state. And in this session you have to discuss about only gaseous state of matter. Then you already know about Maxwell-Boltzmann distribution law. Then velocities of gas molecules. What are the velocities, how they are vary, that can be known about velocities of gas molecules. And last one is effect of temperature on gas molecules, that you have all learnt in PVC level or under high school level. Now coming to the actual, that is the concept of this session. Now coming to the first one is distribution, that is the introduction. Need of Maxwell distribution, Boltzmann distribution law. While deriving the kinetic gas equation, it was assumed that all molecules in gas have the same velocity, but it is not so. When any two molecules collide, one molecule transfers kinetic energy, that is half mv square, to the other molecules. The velocity of the molecules which gains energy increases and that of the others are decreases. Now here this say that while deriving the kinetic gas equation, it was assumed that all molecules in a gas have the same velocity, but it is not so, because here molecules in the matter, particular gas molecules, they are not stationary, they are continuously random in motion. While moving from one place to other place, the one molecule hit to the other molecule, means that is the one molecule collide with other molecule. Therefore earlier molecule hit to the other molecule, no, that earlier molecule energy will be a decreases, or speed will be a decreases by transferring the energy, kinetic energy, half mv square to the other molecule, and other molecule, that second molecule, gain the velocity, and the further it is hit to the other molecules, and their velocity again decreases. Such therefore, because of number of or millions of the molecules present in the particular gas system, and the number of collisions, no, the number of millions of the collisions are takes place in per second. Therefore the velocities of molecules are constantly changing, but it is not a constant, or it is not a same. Therefore the Maxwell and Boltzmann explain this like that, since the number of molecules is very large, because the number of molecules are much more in the system, therefore the fraction of the molecules out of the plenty of the molecules, some molecules having the same type of the energy, that is a particular type of the energy. Therefore, suppose we consider a institute contain 100 staff members. Out of 100 staff members, some staff members having the common sense or that is thinking powers are same. Therefore, that is called as a fraction of the staff members having the same thinking capacity. Like that, we say that the fraction of the molecules will be the same particular velocity. In this way, there is a broad distribution of velocities over different fraction of molecules. In 1860, James Clerk, Maxwell and Boltzmann calculated the distribution of velocities from the law of probability. Then coming to the mathematical expression for Maxwell-Boltzmann for velocity distribution law. And they given that is the equation, that is the expression, that is the dnc divided by n equal to 4 pi into m divided by 2 pi rt whole to the power of 3 by 2 e to the power of minus mc square divided by 2 rt into c square dc. And this expression is called as a Maxwell-Boltzmann velocity distribution law expression. Okay, where R is nothing but real gas constant, that is nothing but 8.314 joules per Kelvin per mole. Then dnc divided by n, this is the fraction, no, this is number of molecules, the fraction of the molecules having the velocities between c and dc, means particular velocity and change in velocity. The molecules having the belonging to these, no, therefore these are the a fraction of the molecules having the velocities between c and c plus dc. Then n is nothing but total number of molecules present in the gas system, and m is nothing but molecular mass of each gases, no, the gas molecules, and T is nothing but temperature in Kelvin. These are the terms involved in this expression, and this expression is called as a mathematical expression of Maxwell-Boltzmann velocity distribution law curve. Then coming to that is the explanation of velocity distribution curve based on the law of Maxwell-Boltzmann, based on the law of Maxwell-Boltzmann. Now coming to that is here how it is explained, that can be explained by using the silent features. The silent features of Maxwell-Boltzmann distribution of velocity in nitrogen. The Maxwell and Boltzmann taken that is a nitrogen for study here, and they explain that is their feature, what are the features or what are the properties of nitrogen gas molecules possesses at 300 Kelvin temperature and also at 600 Kelvin temperature, and they are concluded in the form of features. Therefore, that can be an explanation of that is silent features of Maxwell-Boltzmann distribution velocity in nitrogen gas. First feature goes to a very small fraction of molecules has either very low velocity or very high velocity. Suppose because millions of the molecules are there, no, out of millions of the molecules there, no, the small fractions of the molecules either having a very high velocity or a very low velocity. They may be high or and other having a very low, and intermediate, no, then some molecules having a the same velocity, like that, no. The second feature is nothing but most intermediate fractions of molecules having a velocities close to the average velocity represented by the peak of curve, and this velocity is called as the most probable velocity. Now here, out of millions of the molecules, gas molecules, the some molecules, the small fraction of the molecules having a either high velocity or very low velocity, but most of the molecules having the average velocity, it is close to the average velocity, and it is represented as a peak, and this is called as a most probable velocity. Therefore, how do you define that is the most probable velocity? By using here, the most probable velocity may be defined as the velocity possessed by the largest fraction of the molecules. We know that small fraction of the molecules either having a high velocity or low velocity, but largest fraction of the molecules having a same velocity, possesses the same velocity, and it is present at the corresponding to, that is the peak, the highest peak in a Maxwell-Boltzmann curve, and that is called as a most probable velocity. And fourth feature is at higher temperature the whole curve shift to the right, means dotted line. At particular temperature, that that is distribution, molecular distribution will be takes place, but as the temperature shifted or increases from 300 to 600 Kelvin temperature, the same curve will be shifted to the right side. This shows that higher temperature, more molecules having a higher velocities and fewer molecules having a lower velocities. And these are the fractions of features of Maxwell-Boltzmann velocity distribution curve. Now here in graph, no, it say that is a graph is plotted fraction of molecules on taken over y-axis and molecular velocity is taken on x-axis at particular 300 Kelvin temperature. Now here the most peak will be there, no, here peak will be there. This portion having a highest peak and this having a same velocity. Most of the molecules are possesses the same type of the velocity, and largest portion of the velocity, largest portion of the Maxwell-Boltzmann curve, and which is possesses more number of molecules of same velocity, that is called as a most probable velocity. And small molecules having a somewhat intermediate molecules having a some less velocity, average velocity, therefore it get that is the average velocity. And least velocity, highest velocity, actually highest velocity will be there, that is having a root mean square velocity. Therefore here it indicate as a three types of the velocities will be there. One is the most probable velocity, second one is average velocity, and third one is root mean square velocity. Root mean square velocity means the fraction of the molecules having a highest velocity, they are called as a root mean square velocity. And some molecules having a less velocities, that is the average molecules, average velocity, that is having a some molecules. And most of the molecule possesses the same type of the velocity, and that is called as a most probable velocity. Therefore, suppose we consider for understanding purpose, suppose 100 people are there, 100 people, consider 100 people in a institute. Therefore, the very few people having a high velocity, means some or more knowledgeable people will be there, and therefore they called as a highest velocity, means just out of 100 there may be 20 people will be a more intellectual, and therefore it is called as a root mean square people, or root mean it is a square people. Okay, second one is some molecules, no, 30, it say that is 25, no, 20 are nothing but we say 20 peoples are it having a root mean square velocity, and 25 peoples having a average velocity, means somewhat that is a moderately will be there, moderately intellectual, and they are called as a average velocity peoples. And other less than that means some molecules, the remaining, no, that is 55 peoples remaining, that is 55 peoples having a very less velocity, means common velocity, common thinking capacity will be there. Therefore it is called as a most probable velocity people. Therefore we say that suppose molecules are suppose 100, it is 100 molecules will be there. Therefore only 20 molecules having a more velocity, and therefore it is called as a it is the root mean square velocity. And 25 molecules having the some type of the energy, and that is called as a average velocity. But remaining, that is out of 100, no, that is 45, from 45 is gone, no, then remaining, that is 55 peoples having a very less, more energy, it having a very high energy, sorry, they having a same type of the velocities, the 60 molecules having the same velocity, and hence it is called as a most probable velocity of the nitrogen molecule. As the temperature increases, the velocity distribution curve will be shifted towards the right side. This can be explained by using a Maxwell-Boltzmann distribution law. Then coming to that is in this session, therefore so far we have studied about what is the need of Maxwell-Boltzmann distribution law, why it is the need to derive, explain, that is that can be explained. Then what is the expression of Maxwell-Boltzmann equation, that you have already know, and what are the silent features of Maxwell-Boltzmann velocity distribution curve, you have already known. And last one is what is the nature of Maxwell-Boltzmann velocity distribution curve, you have already known. Therefore, after this the completion, no, now what you have understand, that by checking, by using a evaluation, I will ask some question and then you have to answer. Now first question will be goes, the molecular velocity distribution law proposed by, here 5 options are there, one will be a correct option, you have to choose. First option goes to RNS, second one is Newton, third one is Maxwell-Boltzmann, and fourth one is Watson and Crick. These are the 4 options are there for this answer, this question. Write correct option. I will give, that is a 10 seconds for you people, you have to say. Answer for this question is nothing but C option, Maxwell-Boltzmann, that is proposed the molecular velocity distribution law. Okay, therefore C option is the correct answer for question number 1. Then come to the question number 2. The state, that is the state of meaning of d and c by n. What is the meaning of d and c by n? Here first option goes to number of molecules having velocities greater than c and c plus dc. Second one is number of molecules having a velocities lesser than c and c plus dc, and number of molecules having a velocities between c and, that is c plus dc, and d is nothing but none of this. I will give, that is just 10 seconds for you people, you have to select correct option. Here the C option is correct option. The number of molecules having the velocity between C and C plus dc. This is called as a dnc by n. Okay, therefore C option is the correct answer for this question. Then third one is value of real gas constant. What is the value of real gas constant? 4 options will be there. One is 8.314 joules Kelvin per mole. Joules Kelvin per mole. Then B option is 8.314 Kelvin calorie per, that is kilocalorie per Kelvin per mole. Kilocalorie per Kelvin per mole. Then C option is 8.314 joules per Kelvin per mole. And D option is none of these. Just I will give, that is a 10 seconds for you people, you have to choose the correct option. The C option is the correct answer for this question. The 8.314 joules per Kelvin per mole is the right option or right answer for value of real gas constant. Then fourth one, in a graph, fraction of molecules versus temperature. At higher temperature, this curve will be shifted to, first one is A1 is right, B will be a left, C will be a top, and D will be a bottom. These are the option, and you have to choose the correct one. I will give just 10 seconds for you people. The answer for this question is, that is A option, that is the right. As the temperature increases, the curves will be shifted towards the right, and this is the A option is the correct answer for this question. Then fifth question goes to Maxwell-Boltzmann equation distribution curve of velocities in. The Maxwell-Boltzmann explain the distribution of velocities in. A option, chlorine gas molecule, B1 hydrogen gas molecule, C1 is helium gas molecule, and D1 is nitrogen gas molecule. You have to choose correct the answer. I will give just 10 seconds for you people. Answer for this question will be a, that is the D option. It is a nitrogen gas. Here in this session, the Maxwell explained the velocity distribution in nitrogen gas. Therefore, D option is the correct answer. And therefore, this complete that is session. And for that, I have made some references. This session was made by using these references. And this complete this session. Thank you.